Welcome to my channel. Today we see the applications of hyperconjugation effect here. In my last video I told you the definition for hyperconjugation effect here. Once again I tell you the definition alone and then move to the applications. First one, what is the definition for hyperconjugation? An alkyl group, you see an alkyl group, suppose I take the alkyl group, this is CH3 CH2. The alkyl group attached with a unsaturated system like carbon-carbon double bond, or it is attached with carbonium ion, or it is attached with a carbon free radical. A alkyl group which is attached with carbon-carbon double bond system or carbonium ion or carbon free radical, this alkyl group must possess what is the condition to show the hyperconjugation effect? It should have here alpha hydrogen, at least it should contain one alpha hydrogen. What is alpha hydrogen in this case here? That it is called as here functional group. To this, the attached carbon atom is called as here alpha carbon. So it contains how many alpha hydrogen? It has 2 alpha hydrogen. So something like that. Suppose to this here carbonium ion I attach here. To this here carbonium ion I attach here one group. This is what is that here? CH3. I write here it is CH. It is 2. It is CH2. This is called as here. Here to know which is the alpha carbon, this is called as here alpha carbon. This carbon containing hydrogen is called alpha hydrogen. Suppose I take this I take here free radical. For an example, I take free radical, I take ethyl free radical. This is called ethyl free radical. It is called alpha carbon. This alpha carbon containing hydrogens are called alpha hydrogen. So what is called hyperconjugation? The alkyl group which contains at least one alpha hydrogen is attached with carbon-carbon double bond or carbonium ion or carbon free radical. That is called carbon free radical. The ability of this alkyl group to release electron is called as here hyperconjugation. To release electron is called as here hyperconjugation. This hyperconjugation is otherwise called as here already I said it is called no bond resonance. It is called as here no bond resonance. Now we move on to then how to find out the order of that hyperconjugation effect regarding alkyl group. I take here tertiary CH3, it is thrice carbon. This is one group. Then secondary, you come to CH3, CH, it is twice. Then last one I take CH3, CH2, single bond here. Then here you see in this here it is called as here alpha carbon. It is called alpha carbon. If it is attached with this group, it is called as here alpha. Because this alpha, alpha contains 2 hydrogen. Here this is alpha here. This is called alpha carbon. This is alpha carbon. Alpha carbon contains 1 hydrogen. Here it has here no alpha. It has here no alpha hydrogen. Here it is the absence of alpha hydrogen. So in this here, this is the group. The primary, it shows here higher hyperconjugation effect than secondary. Secondary shows higher hyperconjugation effect than tertiary. Right. Then I take here carbonium ion. I take here carbonium ion. Right. I take here what carbonium ion? I take carbocation. Carbocation is otherwise called the carbonium ion. I take tertiary carbonium ion. It is CH3, it is CH3, it is CH3. I take secondary, it is CH3, it is CH3, it is H. Then I take primary, it is C, it is H, it is H, it is CH3. It is here primary. Right. You find out here in which carbonium cation. All these carbonium cations are unstable. You all know that here. But now I compare the stabilities of all these, which has little higher stability than another one. Like that we want to know. To see that it is called alpha carbon. How many alpha hydrogen it has here? 3 alpha hydrogen it has. Here how many alpha? Here this carbon attached one is, it is alpha. So here 3, here 3. Totally 6 alpha hydrogen. 6 alpha hydrogen. Here how many? Here 3 3 3 9 alpha hydrogen. If it has here 9 alpha hydrogen, how many hyperconjugative structure it has? How many hyperconjugative structure it has? I already said it is n plus 1. N is number of alpha hydrogen. How many alpha hydrogen it has? 9. 9 plus 1. So it shows here how many hyperconjugative structure. That is 10. Here it has here how many hyperconjugative structure. That is n plus 1. What is the n value? It is 6. 6 plus 1. That has here 7. Here how many hyperconjugative structure it has? N plus 1. It is 3 plus 1. That is equal to 4. Here you all know that here number of hyperconjugative structure increases, the stability increases. So this one is more stable than this. It is more stable than this. It is regarding carbocation. Then you come to free radical. Free radical. What are free radicals? Same thing I take. You see tertiary. It is C. Here it is C. It is CH3. It is CH3. It is free radical. Then you come to here secondary CH3 C. CH3. It is H. It is free radical. Primary CH3 CH2. It is free radical. It is free radical. Now you come to this here. This free radical has how many alpha carbon? You see this is alpha. 1 2 3. How many alpha? Just like here 9 alpha hydrogen. It has how many alpha hydrogen? It has how many alpha hydrogen? These 6 alpha hydrogen. It has how many alpha hydrogens? It has here 3 alpha hydrogen. So here number of hyperconjugative structure for this, it is 9 plus 1, that is equal to 10. It is 6 plus 1, it is equal to 7. It is 3 plus 1, that is equal to 4. So this is order. This is the order. So free radical, tertiary free radical, it is having higher stability than this one. It is having higher stability than this one, because it shows here 10, it shows here 7, it shows here 4. That is regarding the free radicals. Then we will move on to, then I will give here some structures. Clear? I give some structures. Then you will be asked to find out the total number of alpha hydrogen and how many hyperconjugative structures are there. Suppose if I take first one, it is CH3, it is CH double bond CH2. You see, I want to know how many alpha hydrogen it has, how many hyperconjugative structure it has. Now this is carbon-carbon double bond. You take this. It is alkyl group. How many here alpha hydrogen it has? 3 alpha hydrogen. So conjugative here n plus 1. So it is 3 plus 1, that is 4. How many structures it shows here? How many here hyperconjugative structure? It shows 4. Then we will move on to this CH3, CH2, CH double bond CH2. Then you come to the carbon-carbon double bond. Alkyl group attached. This is called alpha. How many it has? 2. So it has 2 here, 2 plus 1, 3. That is. Then I come to this C double bond C. Here I take here it is CH3. I take it is CH3. I take it is CH3. I take here it is H. It is this. The carbons which are attached to this carbon is called alpha. So it is a functional group. Alpha, alpha, alpha. 3, 3, 3. Totally how many hydrogens here? 9 alpha hydrogens it has. So how many structures? Now 9 alpha hydrogens. So how many structures it shows here? 10. 10 structure it shows. Then only one I take. Then here I take. Here I take here. One more structure I take. You see. Here I take CH3, CH, single bond CH3. It is isopropyl carbonium cation. Then this is, you see, alpha hydrogen here, this 3 plus 3 totally, how many alpha hydrogen? 6 alpha hydrogen. How many hyperconjugative structure it shows here means 6 plus 1 totally 7 it shows. Then I take here butyl CH3, tertiary butyl CH3, single bond CH3, it has here plus. How many? 3, 3, 3, 6, 3, 9. 9 alpha hydrogen. How many structure? N plus 1 I told here it is 10. So 10 hyperconjugative structure it shows. So this one. I take here some other compound and I will tell you here about the stability. I want to tell you here about the stability. Suppose I take here these two compounds. You see, I want to compare the stabilities of two compounds. I take C double bond C. to this one CH3, to this one CH3, to this one CH3, and it has this. And another one C double bond C, it has one CH3, it has one CH3, it has H. I want to know in between these two which has higher stability. These both are called as here substituted alkenes. Substituted alkenes. Want to know that. To know that here substitute alkene, what we need to find out? You find out number of alpha hydrogen. It has here 3 alpha hydrogen, here 3 plus 3, totally how many alpha hydrogen? 6 alpha hydrogen it has. But here 3, here it is alpha hydrogen, it is functional group. The carbons attached to the functional group is called alpha. So here carbon, here 3. Totally how many structures it has here? 9 alpha hydrogen it has. If it has 9 alpha hydrogen it has here, how many hyperconjugative structure it shows here means 10. It has how many hyperconjugative structure it shows here means 7. Hyperconjugative structure it shows. So in between this it shows here more number of hyperconjugative structure, so it is here more stable than this. Yeah. Or they may give here heat of hydrogenation. Heat of hydrogenation. Heat of hydrogenation is inversely proportional to stability. Heat of hydrogenation. For this, what is the heat of hydrogenation? For this is given as here, it is del H equal to minus 27.6, it is kilocalorie per mole. It is given. For this, del H value is equal to minus 28.6 kilocalorie per mole. So you compare these two values, it is 27.6, it is 28. So heat of hydrogenation is inversely proportional to stability. If lower the heat of hydrogenation, that stability is higher. So it is here more stable. You don't see the negative sign, you see this numerical data, it is more stable. This one is more stable. One more I go. This is I take here 2 alkenes. You see I am taking here 2 alkenes. One is C double bond C, here one CH3, here one CH3, here one H, here one H. In the similar way, I take C double bond C, here one CH3, here one H, here one CH3, here one H. For this I give you del H value. What is the del H value for this? It is minus, it is given as here, it is minus value of this. One value here it is given minus 28.6 kilocalorie per mole. This is, it is given here. Now I take here one more. Here it is given del H value is equal to minus, it is given. These two are given. But you compare these two here, it is called as here that similar groups are opposite to each other. That is called trans. It is called a trans. Similar groups are here on the same side. It is called as here cis. It is called as here cis. It is called as here trans. It is called as here cis. Is it not here? We want to compare both these. Whether cis is having higher stability or trans is having higher stability, we want to know. To know this here, what we need to compare, it has here alpha hydrogen 3 plus 3, here 6. It is also 6 alpha hydrogen. It has here 6 alpha hydrogen. Right. But you see, number of alpha hydrogen same. It has here how many here hyperconjugative structure? It is 7. It has how many? 7. Hyperconjugative structure 7. If both these are same, but how to compare these here means, in this here, you see, both this group, that is bigger groups, are close together, but in this here they are opposite. If they are opposite, we don't have here much repulsion, but here more repulsion is there. So trans is always higher stability than cis. So this one is here higher stability than cis. Only here I see one more example for comparing the stability. The compound, first one what I take is here, this is second compound like this. Here one methyl group, here one methyl group, here one methyl group. Here it has double bond, here it has double bond, here it has double bond. What is asked in this? Out of these three here, which shows more number of hyperconjugative structure and which one is the most stable? But you see this one carbon-carbon double bond. carbon double bond. To this carbon attached this carbon is called alpha. To this carbon attached this carbon is called alpha. To this carbon attached this carbon is called here alpha. So totally how many alpha hydrogen it has? 3, 2, 2. Totally 7 alpha hydrogen it has. Now we come to this, it is called carbon. To this carbon, it is functional group carbon, this is called CH2. This is called CH2. So how many alpha hydrogen it has? It has 4 alpha hydrogen. It has, this is here, this here only CH is there, here 1 hydrogen, here how many hydrogen? CH2. So here 2 plus 1, 3 alpha hydrogen it has. So 7 alpha hydrogen, 4. If the number of alpha hydrogen is 7, how many hyperconjugative structure it shows? 7 plus 1, 8 hyperconjugative structure. Here 4 plus 1, 5 hyperconjugative structure. Here 3 plus 1, 4 hyperconjugative structure. So out of this here 3, it shows here highest number of hyperconjugative structure. So it is most stable. It shows here least number of hyperconjugative structure. So this one is the least stable. So this is the order of stability. Thanks for watching my video.